It's fun. We'll get rid of that. And we will start talking about student laboratory safety. And I'm just going to bring everything up here. And I don't know why it flashes. That concerns me. I'm going to bring everything up, and you can write this stuff down. Now, these are the answers to the questions on that sheet where it says who is responsible for safety in the laboratory. It's you. The biggest danger in the lab, again, is you, because you are in control of your actions, and appropriate actions in the laboratory are a must. You must behave appropriately in a lab situation. Why are you the biggest danger? You may work carelessly. Not that we're giving you permission. It's a possibility. We don't want you to, and you may not know. You may not know what you're doing. Give me an example. Give me a situation of how being careless and maybe even goofing around in the lab. Why would that be such a dangerous situation? Why is it so dangerous to just even something that you might think is funny in the hall, a little push, hey, that type of thing? How could, if you say push somebody in the lab, how could that be such a dangerous situation? Yep. Exactly. A Bunsen burner is a perfect example. Something that's creating a lot of heat. It takes no time to get an arm or a limb in the hot part of a Bunsen burner flame, and it can do a lot of damage. Not knowing what you're doing, mixing chemicals incorrectly can result in unintended reactions, which can be very dangerous. Now, the chemicals we work with here in high school, who's kidding who? They're pretty tame. We've removed anything that's really dangerous. Like 20, 30 years ago, there was some pretty, dangerous stuff. Carcinogens, things that are cancer-causing. They've all been removed. So we don't have a lot of real dangerous chemicals. But a classic example of mixing things that maybe you're unaware of, even household products. If you mix chlorine bleach, right? If you mix that with, say, an acid, okay? So you might have something like a cleaner. At my house, there's a lot of iron in the water. I live out on a farm, and the farmhouse has well water, and there's a lot of iron. So there's a lot of iron deposited in the toilets and in the bathtub. And there's a chemical you can use to clean it, and it's a very strong acid. And if you were to mix that strong acid with, say, a bleach cleaner, those will undergo a reaction and produce chlorine gas, which is very dangerous. You don't want to inhale chlorine gas. So that's an unintended reaction if you were to have those two mixed together. So theoretically in a laboratory, if you were to indiscriminately mix things, you could get a very dangerous unintended reaction, all right? Now, like I just said, we do not have, you don't need to put the title again. This is an ongoing scenario, so you don't need to put that title. Like I said, in the laboratory, we do not, here at in a high school, we do not have very many really dangerous chemicals that you'll come in contact with. Now, in my chemical storage room, those dangerous chemicals exist in concentrated forms. So when I'm working in there and mixing things and diluting things for you, I need to be very careful. We have concentrated hydrochloric acid that's always giving off some chlorine gas. And if I don't do that in the fume hood properly, right? If you had Mrs. Murray, you probably heard me in the back room sometimes mixing things up. I had to do it in that fume hood, because if I do it out in the air, those fumes take over, and you've got to really be aware if you're dealing with the strong stuff. 3 things to prevent carelessness: think before you act, concentrate on what you are doing. If an accident occurs, keep calm and inform your teacher. 3 things to help you know what you're doing. Listen carefully to instructions and warnings. Read all written instructions in advance. Ask first if you are not sure what to do. Reading instructions in advance. In the past, when we worked with paper, I'd give a handout just before we do the lab, so it would be difficult to read in advance. Tomorrow, we'll be doing this experiment that deals with the Bunsen burner. After school, I will be putting the assignment right up on Google Classroom, which means if you have time tonight as some homework, I guess, you could theoretically open that up and read through the instructions so that you've read the instructions before you come to class, because I'll be posting those, like I said, after school. I posted something earlier today, and I'm just asking just as a curiosity. On the Google Classroom app, you can activate notifications, right, where it gives you a notification like anything else does. When I post an assignment, does a notification come to you? Did it notify you? So when I posted the MSDS assignment, a notification came up? Yes? There you go. So if I post later on today the Bunsen burner lab, you will then know that it's being posted, right? Awesome. I do not know the writing speeds of everyone. Let me know if I'm jumping ahead. Also, if you're a faster writer, you could open this PowerPoint up on the day's work page on your device, and you could be writing ahead of us, right? And then you don't have to wait for me, but you don't have to. That's something that I've noticed some other students doing in the other classes. Good to go? No? Isaac's still looking up? No, that's okay. No problem. I will find it and I will write it on. Goodness gracious, memorized? Somebody's memorized the code? Nice. It's impressive. I think I'm good to go at this point. Yes, still waiting. Again, the title, don't mind it. It's just we're going through the numbers on the sheet. Many of you either had your parents, or if you're 18, did submit that back on the fact that you've read over the course statement. That's excellent. I'm going to take some time either this evening or after school, and I will be replying with your code that will then let you know what your mark update is when we get to a mark update. 6 major dangers in the lab: cuts and burns, eye damage, electrical shock, poisoning, fires, explosion. Yeah, we have potential for all of these. It's exciting. We're going to be safe, though. It's not going to happen. We do have a couple of labs where we do use some electrical equipment. Again, this information is coming from that sheet, and you indicated to me, Mark, that you couldn't get that sheet. It didn't come up. I was able to bring it up, the sheet. You couldn't bring that sheet up? This morning you could? Well, I'm wondering. I'm wondering if it's because of the link, that we didn't have the link, and so you couldn't bring it up because the link wasn't there. Now the link is there. You know what I mean? Because I've shared it. Right. You couldn't find it. Now the link is there. The link is good because I checked the link. Okay, we good to go? Good to go. General rules, and I do want you to write these down, and then we will go through them. I'm not going to talk through as you're writing. I want to just talk a little bit about the safety equipment in this room, along with our evacuation procedures. Okay, we're probably getting close to the bottom. I'm going to just discuss a few of these. You can keep writing if you're not done. Be aware of the location and the use of safety equipment in the lab. So in this laboratory, you can see that there's a few safety items in here, and there's going to be some also in the other lab. And tomorrow, hopefully, if I forget, remind me to point them out to you, or just take a look for them. They look very similarly, and they all have the same function, but we will be working in that lab when we do our experiments. But just to go over some of the safety equipment, here we've got the fire blanket, all right? And the other fire blanket looks a little different, but all fire blankets really function the same way. They'll have some kind of handle or something at the bottom. In this case, you got to pull this Velcro, and that fire blanket will either fall out or you can pull it out. And essentially, if there's something on fire, you can cover it with the fire blanket. It's a non-combustible material, and it will extinguish the fire. I have had a backpack on fire in class before. They claimed it was spontaneous combustion, but I don't believe that. Someone started someone else's backpack on fire, and I just used the fire blanket and covered it up, and it worked quite well. If someone's clothes are on fire, you should never wrap the fire blanket around someone who's standing up, because what happens is the fire blanket starts to act like a chimney, right? So the warm air will rise up to the top, and as it does that, it's going to draw more fresh air in, and it just gets going faster and faster, and all you're doing is incinerating your friend faster than they would if they were just standing there on fire. So if your clothes are on fire, you stop, drop, and roll like you're taught, for years, and then the fire blanket is placed over top of the person who is lying down on the ground, all right? In terms of other equipment, here's the fire extinguisher. But if we have a fire such that a fire extinguisher is needed, you will not be using the fire extinguisher. I will be using the fire extinguisher and deciding whether I have the ability to put it out or whether we leave. Actually, if that's the case, I am sending you out to leave as I make that decision, all right? In terms of where we go when we leave, if we are evacuating due to a fire drill or whatever, you're going to leave here and you're going to go right, all right? Even if we're in room 118, you're then going to go left. We're going to head that way, all right? We're going to head north. And then you're going to turn left at Albert Einstein there at the co-op room, out to the tech hall, and then across the street at the North Tech Hall doors, right? Right? Yeah. Mark's one of my only guys who went right in the last 16 years of teaching here at Petrolia. Anyway, left, Mark. Go left, and then across the street. All right, excellent. So that's our evacuation, okay? Since I'm talking about evacuation and other procedures before I move on to the other equipment, if we have a tornado drill, you're taking your book out into the hall, and if we don't have our books with us, you take a binder, and if you don't have anything, it's not a big deal. Then you sit and you face the wall, and you stay away from the windows, and you stay away from the doors, all right? And I will be out there to guide you around. If we have a lockdown situation, then we will be moving across the room, and we will hide in the shadows of the lab benches, all right? And we would do the same if we were in 118, right? You think about where the doors are, and you simply go into where those shadows would be if, someone was shining a light through there, because that's what they would see, right? So we will hide in the shadows, and then we will wait until we're given the all clear. So other safety equipment in the room, here we've got the eye wash station. It's pretty self-explanatory. If you get something in your eye, right, you get the goggles off, because hopefully you had the goggles on. Don't worry about the little plastic pieces. Just push that forward. They'll fly off. The water will fly everywhere. Don't worry about the water flying everywhere. You put your eyes in those streams. And they say keep it there for 10 to 15 minutes. Now, that's pretty tricky if you're, got some cold water. But we do not, again, deal with anything that I give you that is strong enough to really cause any damage. So we would be fine, with maybe 5 minutes or something. But I would be there to assist you in that case. Another safety feature of the rooms are the power shutoff switch right here, the emergency shutoff switch. Don't push that just for fun. It does shut off all the electricity to the room. So that means my computer would shut down, and then we'd have to restart the computer. It's kind of a pain, all right? So emergency power off will shut the power off to anything that's plugged in the room. So if you have a device that's causing someone to be electrocuted, don't go and grab them to help them. You'll just become part of the circuit. We shut off the power here. Our gas jets are also supplied by an electric pump, which means from the gas feed line, there's an electric motor that's pushing the gas out this way, all right? So if there was a malfunctioning Bunsen burner or something that was being so dangerously on fire and the gas jet was on, pushing that button also shuts down the gas supply, okay? I don't know. I've never tried that. Does it shut off the water too? Oh. There's a fire and shut it off. I've never checked that one out. That would be new. There you go. I know it's all on electric pumps, so it could be the water as well. I do know that the water sometimes pulses, which implies that there's an electric pump at work. That's cool. All right, I didn't know that. Okay, wear proper safety equipment when working at the lab bench. Proper safety equipment for me is footwear, all right? So tomorrow we're going to do a lab, and I'm going to ask you to bring proper footwear. I have a Twitter account, and it's linked. You can see it on the page. I often, will send reminders. Don't forget to wear proper footwear. So then you get a nice, that type of thing. Oh, footwear. Mr. Sanders is sending a tweet. Anyway, so footwear to me consists of something that's going to cover your feet completely. So those shoes are acceptable. That's great. But those shoes, not as acceptable because the top of your foot is exposed. You see what I mean? Years ago, we used to just say closed-toed shoes. But then your toes are covered. But what happens if like a piece of a broken, who knows what beaker comes along and just kind of sticks in the top of your foot there? You know what I mean? Blood everywhere. That wouldn't be good. So I want you to wear like sneakers or something that covers the top of your feet. All right. So please have that for tomorrow. And we do quite a bit of little labs in this particular course. So I would ask you that you have this, you know what I mean, nearby. I even considered, because we have access to just the laboratory, if you'd like, because nobody's using that room, we could even just keep, you know what I mean, if you've got a pair of shoes that, you're not taking phys ed, but you've got shoes that you want to just leave in the room, you could do that. I wouldn't have any problem. There's some shelf room. You could just leave your shoes there if you wanted to do that. That might even be a thing that we can do. Okay. Always read instructions before you start any part of an experiment. Always stand while doing an experiment. If something were to spill or the Bunsen burner were to fall over, you can then simply step away. If you're sitting down, there's no way you can get out of the way fast enough. Clean your equipment before use. I'm a fan of cleaning it when you're done. If you get it nice and perfectly clean when you're done, once you put it away, it should be ready to use the next time. So if it looks clean when you get it out of the drawer, we're going to assume it is. We're going to assume the last person to use it cleaned it. Notify your teacher if any accidents occur. Clean up your work area at the end of the lab, and lab work is to be taken seriously. Excellent. Let's continue. Don't worry about writing that down. You share the responsibility for not only your own safety, but for the safety of those around you. Awesome. And now it says there, sign the student safety contract. I'm going to make some copies of the contract, and I'll get you to sign them probably after we're done our quiz on Friday. Okay? Okay. So this was also part of the question sheet, so I do want you to write this down. Now our quiz on Friday is going to be on the safety stuff that we just talked about now, along with these symbols, along with the lab equipment that we're going to talk about as well at the end of today's class to finish off. Safety convention and symbols. Again, if I jump ahead too fast, just let me know. Don't need that title because we've already got the title from you just worked on it. I'm going to bring up the whole thing on WHMIS and MSDS and HHPS. Okay, you can write that down. Now in a moment, I'm going to be showing you all those symbols. And you know what, to be honest, I don't want you to write them all down. Just make a text reference, okay? Whether you're using your actual textbook, I know many of you took them home, and if you're not going to use it at home, leave it here in the room, or you can use the online version. But in the textbook are all those symbols, and you can study them out of the textbook in preparation for the quiz. It is a quiz, for the quiz on Friday. Okay? So no need to draw a little picture of each of those little things. That seems to be excessive. It is page 478 and 479. Yeah, actually 478 has the HHPS symbol. Well, you can see it. It says it right there, HHPS ones, and then 479 is the WHMIS symbol. Yep. WHMIS, Workplace Hazardous Material Information System, provides workers and students with complete and accurate information regarding hazardous products. It's something I have to do every year. I have to do a little, run through a little online program where I watch a little videos, and then they ask questions about, material safety data sheets and workplace labels and all that type of stuff. We're not going to go into the same detail as I do, but perhaps you already have done some WHMIS training. How many people have done WHMIS training for their jobs? Excellent. What jobs are we talking about? Sorry? Working for the township? Excellent. You mean out of mighty Watford, Ontario? Like you watered those plants all summer long? Oh, nice job. Nice. That is, I saw those people many times. You must wear sunglasses to hide yourself because I didn't see that it was you. Or I would have stopped and embarrassed you. That's a very important job, keeping the flowers watered in Watford. Okay, who else? What else did you have? Yep, what job? But specifically, where were you working at? Oh, that's cool. Yeah. I guess, you'd have air tanks, right? And they would be, that would be the compressed air classification, et cetera, et cetera. Oh yeah, that'd be part of the curriculum. But still, for most jobs, you'd have to do it. Have you taken WHMIS? What for? Yeah, the co-op, of course, right? There's all kinds of chemicals there. Yeah. For the high schools major. Yeah. Yeah, I could do it, and some teachers, they do use that where you got to run through it, but I don't bother. I just have it as part of the introduction quiz. I know usually I get a lifeguard out there. Somebody's lifeguard. Yeah, that's good because lifeguard you gotta take care of the chemicals and all that stuff, and you gotta know how safe they are. Yep. You told me about that one last time, didn't you? Or was it this summer, or did you tell me about it last time? Well, that's exciting. That's really exciting. Yeah, there'd be all kinds of chemicals there. You bet. Well, when you get a job, you will have to have WHMIS training. It's just the way it works. You must have that particular training. Okay, MSDS stands for a Material Safety Data Sheet, and these are the pieces of paper that tell you how dangerous a particular product is. And I've got a little assignment that's on our Google Classroom that you may have looked at that deals with those, and I'll talk about that right now for a moment. So even if you're not done writing, I'm going to go to Google Classroom and just show you what that looks like for a moment. So here is our stream. And again, this is my view. It's a little different than yours. Again, don't forget to get that course statement checked. Don't worry about the how to complete an existing document. You can do it if you want. Completing the Google form, remember, that's the information sheet. I'd like that one done. But this one up here is going to be worth some marks. And you'll notice it's due Monday, September 14th at 11:59 p.m. Okay, so I like to put it right at the end of the day because then that gives you late workers a chance to work to get it done. So what is this assignment about? Well, here let me show you what an MSDS sheet looks like. So you will be able to edit this particular document. So it's going to be like an edit one. So when you go to My Work, right, that document, MSDS, should be there, and you should be able to open it up and fill in the blanks by typing in your answers. Where are you going to get the answers from? You're going to get them from these MSDS sheets. You'll notice I've given you 2 copies. Let's take a look at the ethanol MSDS sheet. So MSDS sheets have to be supplied by chemical suppliers. This one is obviously by a company called Fisher Scientific. And notice we're talking about ethanol, and here we've got some synonyms, grain, alcohol, et cetera, et cetera. Part of the assignment will be to go through this sheet and pick out the information I want you to find. Now, even though different companies make MSDS sheets, they all must contain the same type of information, product information, hazardous information. If you go down here, I've gone too fast, first aid measures, fire relief measures, etc., properties, etc. You'll notice I've given you a second MSDS sheet because I found one didn't contain all the information I wanted you to find. So if you're not happy with the answer coming out of one, take a look at the other one. But what I want to get across here as well is all the sections are always labeled the same on all MSDS sheets. Section 1 is always chemical information. Section 4 is always first aid measures, okay? So it should be easy for you to find the information. What do I want you to do with that? When you open up this particular document, you're going to have your own copy, so you're going to be able to edit it. And so in the space, again, we're waiting for the internet. The internet is so slow. So you can see here, and don't worry about the day's work page. That was an old thing. You can just open it. And it says, what are 3 synonyms for ethanol? Click on your document and type them in. Who's kidding who? You could cut from the PDF and paste it in if you'd like. You're just gathering research. You see what I mean? You could do a Control-C, Control-V, you know, that type of action, right? You could do that. Now, what I do ask you, when you do a fill-in-the-blank type thing, like our lab tomorrow, either make your writing italics, you know how you can block it and make it italics, or make it a different color so that when I'm marking it, I can see where your answers are and it doesn't just all blend in to my document. You see what I mean? If you could do that, does that make sense? So you're going to be looking at what are the target organs. So you're going to be looking at section 2, list health potential effects with ingestion of alcohol or ethanol. Be careful because there's also health effects on like getting it in your eye or getting it on your skin or inhaling it. I just want ingestion, okay? And you're going to go through there and you're just going to answer those things. And notice I've got 4 marks for target organs. Means I'm looking for 4 things, right? Make sense? And as I scroll down here, it's going to go on and on. It's going to talk about some physical state and its appearance, and you'll find that in section 9. And in the end, you will then continue on. Part B, it starts right there. What are synonyms for methanol? That's the other one I want you to look at, okay? Same type research except for the methanol sheet. And then at the very bottom, I want you to answer a few questions on this, and if it looks a lot like what you did in the other class, it is a lot like what you did in the other class. We do this in the grade 11 class as well. It's like a startup little thing. Compare the effects, 4 marks, all right? Please support with information that you found, right? Tell me, so it says here, compare the effects of ingesting ethanol to methanol. Ethanol is found in beer, wine, and liquor. Why would we rather want ethanol than methanol in these products? So you're going to make an argument on why, you know, I would think ethanol is safer than methanol, right? So you're going to be specific. Tell me if it affects an organ, what organ does it affect? You know, why is this the way you want it? So again, you can just type right in there and answer those, okay? All right? Okay, and then there's a few questions that you need to answer down at the bottom, all that good stuff. So if I drag down to the bottom, we get to the bottom of it here, and that's the end of it there. All right, right at the bottom, and there it is right there. Ends in number 4. That's the 3rd sheet. There's only 3 sheets to it. And that's going to be due at the end of the day, Monday. Okay? Everybody understand how that's going to work? All right. Try to give it a look before, you know, Monday, so that if you struggle to find the document that you need, I can help you find it, right? So that you're looking in the right spot. Okay, let's continue on. HHPS stands for Household Hazardous Product Symbols. So these are the symbols you'd find on consumer products. So let's say you buy some hairspray, and that hairspray is in an aerosol can, and you go to throw it in the fire, and someone says, whoa, 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 you don't want to throw that in a fire. And the reason you wouldn't want to do that is because it's going to have a symbol on the side of it that says may explode. Those are the symbols that you see on household products. So let's now take a look. And I do want you to write down this. Don't necessarily write HHPS symbols, but I want you to write down the fact that the stop sign is danger, and it is the most dangerous, and that the diamond is warning, It is in the middle. It is in between dangerous. And then the caution sign or the triangle is least dangerous. Now again, moments ago I said don't write down all the pictures because you're going to have access to the book, but I think writing this down isn't too bad. It's not too much. Now at this point in your note, here's where I want you to write down see page 478. See page 478. All right, I could write it down on the smart board. See page 478. Doesn't make sense to copy it all down when you can just kind of memorize it and look at it on the page. We've seen these symbols before, I think, haven't we? Yes, yeah, they're pretty common. They're on, like I said, they're on household products. Again, don't write this down. This is the 478. So corrosive is the hand going into the, into the vat of who knows what. Flammable is obvious. It's the flames. Explosive, that was a little sphere there that's blowing off to the side. And obviously skull and crossbones can't be good for you. So that is obviously the poison. Okay. And here we're just a little quick quiz. Could somebody tell me what the first one then stands for? Yep, Conrad? Danger poison. Yeah, excellent. Danger poisons. How about the second one? Yep. Yeah, awesome. The third one? Yep. Nice. And the last one? Conrad? Danger corrosive. Yeah, danger corrosive. Excellent. You see that one on bleach, right? You see that one on bleach. I see that one on the aerosol cans, right? Also, aerosol cans will have the flammable and then poisonous goodness, probably on bleach as well. So that type of stuff. Cool, excellent, good, nice, nice. Okay, again, don't write this down. We're going to write down maybe under Wemyss, actually write down Wemyss symbols, and then I'm going to write see page 479. See page 479. These are the Wemyss symbols that you would see on labels. Do I even have anything labeled that I can show you? Yeah, this one's getting beat up. This is a container of the clean the whiteboard fluid. You know what I'm talking about? And it's essentially ethanol, right? That's one of the chemicals we're going to look at. So it's essentially ethanol. So because this is in a workplace, I had to make a label for it. And you can kind of see some of them here. This is flammable. It's class B. It's got the long-term toxic. It's on the next slide. I'll show you it in a moment. And then it says what we should wear. Look at here. It says I should be wearing a respirator and gloves when I clean my whiteboard. I don't. But that's what it says. If I'm using ethanol, I should be doing that. So that's an example of, this is not obviously an MSDS sheet. This is a workplace label that I had to create for that, so that if the ministry comes in, I've got it labeled for what it is. The different classes of chemicals, compressed gas, that is a cylinder, right? So if you've taken a shop, you know what the cylinders look like that have the oxygen and the acetylene in it? Yes? No? I guess if you were to think of maybe a scuba gear cylinder, or if you worked with the firefighters, they'd have the gas cylinders, right, that they would have on their backs for a respirator apparatus type thing. Propane tank. Yeah, that counts as one. It's a little fat, short one if you got one. That's correct, propane tank. Okay, so class B is flammable combustible material. Ethanol is combustible. Gasoline, even paper falls under this particular category. Not that exciting. It burns. Oxidizing material. These are chemicals that supply oxygen to combustible materials. Air itself is an oxidizing material. But there are many chemicals that contain oxygen within them, and when they're heated, they will supply a fire with oxygen. There's a chemical that we have across the way called potassium chlorate. There's a demonstration I'm going to do later on with you where you take a gummy bear and you put it into heated potassium chlorate and it burns like crazy. You can use potassium chlorate mixed with sugar to make like model rocket engines, right? You can find all this stuff on the internet if you want. It's not a surprise. But like if you take that chemical, it's a white powder, mix it with sugar, nice together, and pack it into a, one of those little cylinders, put it in the, it'll burn like crazy. Because the potassium chlorate has oxygen within it. And when it burns, it produces oxygen and then allows the sugar, which has lots of carbon, to burn. All right? So in my chemical storage room, I have to keep all of my flammable combustible materials on one side, and I've got to keep the oxidizers as far away as possible, because if they get together, some of them don't even need heat. There'll be enough of a reaction that they'll just spontaneously react, so they must be kept separate. So these things supply oxygen to combustible materials. Class D, toxic materials, immediate effect. So skull and crossbone again, you don't want to touch that stuff. It's not going to be good for you right away. Another part of Class D, toxic materials long-term, all right, and concealed. So that's the type of stuff that might not kill you right away, but if you worked with it for 15 years at a job and you didn't take precautions and maybe it absorbs in your skin or you're inhaling it, it could still have detrimental effects. So that one is to warn you of that. Biohazardous infectious materials. If you've ever been in the hospital, even in the dental, right, they would have that yellow container with that sticker on the side. That's where they'd put their needles or anything that has some kind of biohazard material on it. Corrosive materials, so that'll burn through various types of containers. So the picture here has a test tube dripping some substance on a piece of metal here, and it's reacting. Here somebody's poor hand is there, and it's dripping on their hand, and it's obviously reacting, warning you of the corrosiveness. Dangerously reactive, capital R, with the test tube and the reaction coming out of it. That's the type of chemical that an example of one would be something that actually some molecules contain the oxidizer part that I was talking about and the fuel part in the same molecule. So when it begins to react, one part of the molecule is supplying oxygen, the other part of the molecule is the fuel, and it combusts itself. Examples of that would be nitroglycerin, all right? TNT, it's called trinitrotoluene. There's lots of carbons in there, and there's oxygens flanking them on with these double bonds. We'll talk about that stuff later on, but when the reaction starts, it doesn't stop because you can't separate the molecules. It's all in one. So they're dangerous. Yep. Don't some people spray that in their... Yes. Nitroglycerin can be used as a medical agent. I don't know exactly what it does. It's to alleviate heart arrhythmia. Yeah, and so it's a dangerous chemical. It would be in a solution form, so it would be dissolved in some water, okay, which would make it less dangerous because it wouldn't be as unstable. The water itself would prevent the molecule from either falling apart or from getting to the point where it's concentrated, where it can start this scenario of being dangerous. Yes, that's correct. Yep. So it can be probably made less dangerous by various methods like dissolving it, or something like that. All right? Excellent. Good question. Okay. This particular slide, nothing to write down, but this brings everything together. So there's our compressed gas. There's the types of HHP, as you'd see. Does anybody know where we use these types of symbols in the middle? Anybody know? Have you ever seen them before? Where would you have seen those types of signs? Yeah, you might see them on compressed tanks. Anybody else? I notice them if I'm driving down the road, especially down the freeway when you're passing a car or a truck going slowly. You'll notice on some of the vehicles, they've got the big, kind of diamond-shaped signs. Those are used to represent what's happening, what's inside that vehicle. So if that vehicle were to get into a situation, an accident or something, then first responders can have a look to see what's in that vehicle before they go diving in and trying to, figure out what's going on. So if they see here compressed gas, oxidizing, flammable, et cetera, and they notice some smoke, they're not going to go dive in there right away because they're aware that there's combustible material on board that particular thing. I just put that in there just because I thought it was neat. It's another way of representing that. Don't worry about writing this down. Since we've had these textbooks, some new symbols have come in. This is another one to represent various types of health hazards. It would then have its own WHMIS symbol, and then they've added one that's dangerous to the environment. These are not going to be on our quiz. I'm basing the stuff on our quiz just out of our textbooks because that's what you're going to be studying. But there have been a couple of other symbols added. I do want you to write down First Aid Guidelines, page 484. And I'm not going to go over them right now, but I would like you to read over that in preparation for our quiz on Friday. All right? So that covers the safety and the symbols and the first aid thing. I want to finish today's class by looking at lab equipment and going over some symbols and sorry, not symbols, but looking at lab equipment so that we know what the names are and what those symbols are. And I have put that on Google Classroom. And so I'm going to stop my video and we're going to try to work through this sheet. And I'm going to have you work through it as a group, as a pairs, that type of thing. And we'll see if we can get it to work. It may fail miserably. And if it does, I'll put the answers online so that you've got something to study from. All right? So let me just stop my video here for a minute. And actually, I'm concerned because I don't see it anymore. Nope. Alt-Tab? What are you doing? What are we doing? Alt-Tab? Nice. Who's our techie? Nice. From there? I can't hear very well, so I'm not sure where the voices are coming from.